This is a lecture from Open Tuition. For the free lecture notes that go with this podcast, please visit opentuition.com.
Chapter 8, Portfolio Theory. Now, as it says on page 29 of the notes, the chances of getting asked a question directly on portfolio theory are very unlikely indeed. However, individual bits of this chapter could certainly be asked. And it also serves as a lead into capital asset pricing model, which is the next chapter, which is very important. So although it's not worth spending too long on this chapter, just make sure you are happy with the bits of arithmetic. And what we're talking about here is how we go about measuring the riskiness of an investment, because ultimately it's the risk of an investment that will determine the return shareholders require. So before we can start looking at that, we need to know what we mean by risk. And the standard way of measuring it is paragraph 3 on page 29. It's something called the standard deviation. Now, you may well have heard of this from school or university, but the standard deviation is effectively a measure of the likely fluctuations in a return. To explain what I mean, turn to page 30 where there's a little example. Example 1, it says the following are the likely returns from Z plc and the probability of each of them. And so the returns may be very unrealistic here, but just to illustrate the principle, the returns are either going to be 10%, 15% or 20%. The probability 0.2, 0.5, 0.3. Now, all we mean by risk in a general sense, the risk is determined by the likely fluctuations in the return. If the return was certain, if we were going to get 15% whatever happened, then we'd say there's no risk. The more the returns are likely to deviate from whatever the average is, the greater the risk. Well, here we're asked first of all to calculate the average return. Well, that's certainly something you've all done before. The average will simply multiply by the probabilities and add up. So here, the average return is 15.5%. Now again, if we were certain to get 15.5, we'd say there was zero risk. The fact that here we're not, it may be lower, it may be higher. Well, the further away from 15.5 it's likely to be, the greater the risk. And that's what the standard deviation measures. And all we do is this, we take the returns, I'll call them X. Don't worry too much about symbols here. We've already worked out the average return is 15.5. The standard symbol for that is X with a bar on top, X bar. And we look at the deviations, the differences between the possible returns and the average. So if we take X minus X bar, well, if the return is 10, it's minus 5.5 from the average. 15 is minus 0.5, 20 is plus 4.5. So those are the deviations, the differences away from the average. We want to work out an average difference, but there's no point in working out an average as they stand. The plus, the minus, the average would be 0. And so what we do, we square the deviations. And then we multiply by the probabilities to get a weighted average. Let me show you what I mean. If we square the deviations, 5.5 squared is 30.25. 0.5 squared is 0.25. 4.5 squared is 20.25. And of course the sign now disappears. We've squared them so they're all positive. We then take a weighted average by multiplying by the probabilities. From the question, the probability is 0.2, 0.5, 0.3. And so let's multiply and add. and it gives 12.25. Now that 12.25 is the average of the squares of the differences. That's called the variance. And although the chances of you ever having to calculate that are almost impossible, the word variance can appear in other places in the exam, and so be aware what it is. However, although the greater the spread of the returns, the greater the variance will be, that variance is, if you like, squared percentages. And so to get back to the same terms, we take the square root. The standard deviation is the square root of the variance, which here is the root of 12.25, which is what? 3.5. And we've come back to the same units. It is percentage points. Now, I said a moment ago, for you to actually calculate that in the exam is virtually impossible. Where relevant, you'd be given it, but you are likely to need the figure in other places. Sometimes he might actually give you the standard deviation directly. There we are, 3.5. Other times he might give you the variance. So certainly do be aware that the standard deviation is the square root of the variance. However, it is the standard measure of risk. If the returns were certain to be 15.5 in each case, the standard deviation would be 0, there'd be 0 risk. The greater the spread, the greater the risk, the greater the standard deviation. Okay, so that's what the standard deviation is. What's the relevance of it? Well, for a bit of fun, look at example 2. In example 2, an investor has the choice of the following share investments. And we've got 5 shares there, A, B, C, D, and E, giving differing returns and differing risks. Now, if I just list them, so we've got them in front of us, A, B, C, D, E. The returns calculated, as we had done in example 1, we're given here a 20%, 25, 23, 20, and 22. The risk, the standard deviation, the standard symbol for that is this little sigma, or in fact it's often typed as S, certainly in the exam because it's a bit easier. But the standard deviation is 8%, 6%, 4, 2, and 2. If we were choosing between different share investments, then surely we've 2 criterion now. On the one hand, clearly you want the highest possible return, and on return alone here, you'd prefer B. And yet at the same time, we assume a rational shareholder wants to reduce the risk, and we'd want the one with the lowest risk, which here is D or E. However, surely, in real life, decisions are made the combination of the 2. You will accept more risk, but only provided you get a higher return to compensate you for that risk. And so here, in this particular one, we can't say which is the best of these 5 investments, but we can identify certainly 2 that we'd never choose. One that we'd never choose is A. And see why? Because if you compare, sorry, I can't, here we are. If you compare investments A and B, B gives a higher return. It's better from a return point of view. At the same time, it gives less risk. Well, if you can get a higher return with less risk, there's no question. You would prefer investment B to investment A. So A would never be chosen. Another one we'd never choose, perhaps a bit even more obvious, is D, because if you look at D and D, They both give exactly the same level of risk, 2%. However, D is giving a lower return. Well, if E gives a higher return with the same risk, surely you would never choose to do D. E would always be better. And so we'd never do A and D. However, the other three, we cannot say here which is the best of them, because B, C, and E, they give progressively higher returns. Higher returns. At the same time, they have higher risk. Well, I said before, we will accept more risk provided we get a higher return. And which one we prefer would depend very much on the attitude to risk of the individual making the decision. Every individual reacts differently. You know, the choice between B and C. It would be a question of, did the extra 2% return, did it compensate or not for the extra 2% risk? And we don't know the answer, and you couldn't be asked. So far no problem. We've seen how we measure the risk, standard deviation. Example 2 is just trying to explain the relevance of it, that any decision is a balance between risk and return. Finally, though, and what certainly does stand to be important, is the fact that investors can potentially reduce risk by mixing between investments. It's something that's fairly common sense if you think about it. Do we not generally advise that rather than advise somebody to put all the money in one investment and have the risk involved, it makes more sense to spread their money between investments? It'll reduce the risk. That even if one investment does badly, hopefully the others will do better, that the risk involved will be reduced. To explain what I mean, look very quickly at example 3, and it's certainly not worth spending much time here, it's just to explain the point. But in example 3, the following are the likely returns. A very silly one here, it's only to explain the point. And from investments, though, in ice cream and in umbrellas. That we're saying the return depends on the weather. So depending on whether it's sunny, cloudy, or rainy, if we invest in ice cream, the return will be 20%, 15%, or 10%. On the other hand, if we invest in umbrellas, we sell fewer if it's sunny and more if it's rainy, so perhaps the returns will be 10, 15, and 20. The probabilities, a third, a third, a third. Well, of course, if we invested in just one of those two investments, for instance, ice cream, the average return from ice cream well, I don't need to show the arithmetic. A third of 20, a third of 15, a third of 10. The average return will be 15%. What about the risk or the standard deviation? Well, the deviations, 20 is plus 5 away, 0 minus 5. Square them, multiply by the probability. If I do the two steps in one here, so 5 squared times a third is 8.33. 0 squared is obviously 0, 8.33. The variance is 16.66, and therefore the standard deviation, the square root of that, is 4.08%. So if we invest just in ice cream, the return will be 15, the average return. but it is risky. The return might be higher, it might be lower. The measure of the risk, the measure of the spread, 4.08. And of course, the other option was umbrellas, but surely umbrellas exactly the same. Even though the flows are in a different order, the arithmetic would be the same. The average return is 15%. The risk, different order but the same figures, so the risk again would be 4.08. So there's the return and risk for ice cream and umbrellas individually. So if you choose to put all your money in either one of the two, again, your return would be 15, your risk would be 4.08. However, and probably already very obvious, even with just those two investments, suppose what we did is we invested half our money in umbrellas. Sorry, the other one first. Half the money in ice cream. And half in umbrellas. So we spread our money between the two investments. Well, of course, if it's sunny, half our money will be getting 20% from ice cream. Half our money will only be getting 10% from umbrellas. The overall return will be 15. And similarly, if it's cloudy, 15% on both halves. If it's rainy, half the money gets 10, half the money gets 20, again 15. And so surely the average return, of course, would be 15% as before. We get 15% whatever we do. But the beauty of spreading our money between the two investments is the risk. Well, of course, we don't need any arithmetic here. We're certain to get 15. The risk would be 0. That we've managed, even though there were two individually risky investments, we've managed by spreading our investment between them to end up with the same return, but 0 risk. Now, of course, the chances of things being that perfect in real life is almost impossible. But the same principle applies throughout, that potentially by mixing investments, by spreading our money between investments, we're potentially able to reduce the risk without suffering on the return. Well, that's to explain the principle. However, you could be asked to work out what the risk was as a result of combining investments. Look at example 4. Example 4 on page 33. Uris currently has a portfolio of shares giving a return of 20% with a risk of 10. The risk, remember, is the standard deviation. We're considering a new investment. The new investment also gives a return of 20% with a risk of 12. And so obviously, if it was simply a choice between the two, we'd rather have the current investments. We get the same return with lower risk. However, what we're considering, if you jump to the last sentence, we're considering adding the new investment to our existing investments. We're considering combining them. And it says the new investment will comprise 40% of our enlarged portfolio. And so what we're going to end up doing is investing 60% in current investments, where the return is 20 and the risk is 10. The other 40% of our money will be in the new investments, where the return is 20 and the risk is 12. Now, fairly clearly, if we do that, the overall return will still be 20%. But What will determine whether it's worthwhile or not is the overall risk. Now the return will stay the same. We're currently 20. After doing this, we'll still get 20. The question's going to be, is the overall risk higher than it is at the moment or lower? If the overall risk is lower, then of course it's worthwhile doing. Why should it be lower? Well, look back at that little example. However unrealistic it was, the ice cream one, there was a situation where we were able to combine two risky investments and remove the risk completely. And of course the reason we could is because the flows were negatively correlated. As one gave lower returns, the other gave higher. That was why we were able to remove the risk. And the overall risk will depend on how risky the two are individually and how well they're correlated together. Well, there is a formula to be able to work out the total risk, and you'll be given that formula on the formula sheet. If you look at your formula sheet, it comes under the heading 2-asset portfolio. And the formula as he gives it, SP is the square root of WA squared SA squared plus WB squared SB squared plus 2 WAWB RAB SA SB, which looks awful. In fact, it's quite easy to use, just a bit of calculator work. But of course, the important thing is to remember the symbols. This formula will give you the total risk, the total standard deviation. We're mixing two investments together here, the current investment with the new investment. Well, SA and SB are the standard deviations of the two investments. Here one is 10%, one is 12%. WA and WB are the proportions invested in each. And finally, RA is the coefficient of correlation. Between the two investments. Now, the coefficient of correlation is something you've probably come across before. If you haven't, don't worry. He can't ask you to calculate a coefficient of correlation. It is a measure of how well the investments fit together, but he can't ask you to calculate it. All he can ask you is to actually use it in the formula. So I say you should have seen this at paper F2, but even if you haven't or you've forgotten, don't worry, it's just being able to use this formula. So, let's check for ours. What are the symbols? First of all, WA and WB. They're the proportions in each. Well, it doesn't matter which order, but here, if I let the current be A and the new one be B, it's 60% in current, or 0.6, 40%, 0.4 in the other. So WA 0.6, WB 0.4. SA and SB are the two standard deviations. What are they? Well, the first one, it was 10%, the second one at 12%. Now, incidentally, as you'll see, I'm going to use percents in the equation, and I'll end up with the standard deviation as a percent. If you prefer, use decimals, 0.1 and 0.12, and your answer will end up as a decimal. It doesn't matter. If you're not sure, check it both ways and convince yourself. Finally, RAB It's the coefficient of correlation between the two. Again, you should remember from paper F2 that the coefficient of correlation can be positive, can be negative. It's between plus and minus 1. Don't worry too much if you've forgotten, because you would be given it. In this question on the third line, the coefficient of correlation is plus 0.2. It's now a question simply of sticking it in. So check me SP, the square root of 0.6 squared, 10 squared, plus 0.4 squared, 12 squared, plus 2 times 0.6, 0.4, 0.2, 10, 12. Incidentally, be careful about the sign of this. Here, because the coefficient of correlation was positive, the whole of this last term is positive, but had it been negative, the whole of the last term would have been negative. Which gives us what? 0.6 times 10 squared is 36. 0.4 squared times 12 squared is 23.04. And the last term, 11.52, which is the square root of 70.56, which is 8.4%. Well, obviously check the arithmetic, but otherwise, let's look at the result here. We've got the choice. We either stay as we are in the current position, our return would be 20, and the risk is 10. We could either stay like that, or we could add the new investment. The return will stay at 20%. The risk falls to 8.4. Now the conclusion should be obvious. If we can get the same return with less risk, then of course we will add the new investment. What is quite interesting, we'll explain why later in the chapter, you can read for yourself, but here we were adding on a more risky investment. The new investment had a risk of 12. The new investment was positively correlated with the existing, and yet even so, we'd managed by mixing the two to reduce the risk. Now, it wouldn't always happen, but this does prove to you it is potentially possible to reduce the risk by mixing investments. Okay, well, although, again, to ask this is not that likely. He clearly could ask it because he gives it on the formula sheet. And so, make sure you can do it. Have a go at example 5. Pause the recording, do 5, and then have a check with me. Example 5. We've currently got a portfolio giving a return of 18% with a risk of 10. We're considering adding one of the following investments to our portfolio. The return from each is 8%, so we're indifferent between the two there. They've got different risks though, one's 5, one's 3, and different coefficients of correlation. Which of the two investments should we choose? Well, let's work out. First of all, what's the overall return going to be? Currently, we're getting 18%. And the new one, well, whichever we choose, it'll be 8%. And the proportions in each, well, the new one will be 20% of the portfolio, so currently the current investments will comprise 80% or 0.8. So surely the overall return will just be the weighted average. 0.8 times 18 is 14.4, 0.2 times 8, 1.6, total 16%. So that'll be the overall return. Well, again, it'll be 16% overall, whichever of the two we pick. And so the decision, it'll be a decision based on the risk. And so we're going to have to use that formula. First of all, suppose we take investment A. Use the formula. The overall standard deviation will be the square root of, well, the proportion of the first, if we let current be A and the new be B. Well, the proportion in A is 0.8 squared. Standard deviation of the current is 10 squared. Proportion in the new is 0.2. The standard deviation of the new, remember it's A we're looking at, is 5. Sorry, a bit of a mess here. Plus 2 times the two proportions, 0.8, 0.2. The coefficient of correlation, it's minus 0.7. So the whole of this last term becomes negative. Times the two standard deviations. Current is 10. A is 5. So it's the square root of 64 plus 1 minus 11.2. $7.33. So if we decide to invest in A, we'll end up with overall risk of 7.33%. What about B? Use the formula again. This time SP is the square root of 0.8 in existing, standard deviation 10. 0.2 in B, and standard deviation of B is 3. Plus 2 times the two proportions, 0.8, 0.2. The coefficient of correlation, 0.4. This time it's positive, so the last term stays positive. Times the two standard deviations, 10 and 3. Which gives us %8.26%. And so, which of the two should we pick? Remember, they both give the same return. They both give 8%. The overall return in each case would be 16%. So we're indifferent on return. We'll pick the one that ends up giving us lower risk. And the one we'll pick is in fact A. We'll choose A. That even though A on its own is more risky than B. A's risk is 5, B's is 3. When we combine it with our other investments, the end result, by choosing A, we end up with lower risk than if we chose B. In case you're wondering, of course, an option may be to stay as we are. If we stay as we are, the return is 18 and the risk is 10. If we increase our portfolio and we add, we've decided we would choose A, then of course, although the risk falls to, what was it, 7.33, the return falls as well. The overall return, picking A, fell to 16%. Now, as we said earlier when we looked at a previous example, you couldn't be asked which was the better of those, because even though staying as we are carries more risk, it does give a higher return, and it depends on the individual's attitude to risk, whether that extra return compensated for the extra risk or not. So you couldn't be asked to make that decision. What we can be asked is what we've done here, that if we are going to pick one of them, then without doubt the better of the two is A. Well, as always, check you're happy what we've done in the chapter. Make sure, though, you read page 35 carefully, because that then leads on to capital asset pricing model, which we'll look at in the next chapter.